we're doing a workshop on Tollgate. Tollgate is software that anyone can install on their Wi-Fi router in order to be an internet service provider. So essentially, when you have this software and you have an internet connection, you can sell internet to anyone who connects to your Wi-Fi. Our goal is to enable a free market for connectivity. So how do ISPs work currently? ISPs always need to know who their customers are so that they can send an invoice to the customers at the end of the month to recover the costs that they had for operating the infrastructure and to facilitate basically that customers get access to this infrastructure. But of course, the fact that by design, ISPs need to know who their customers are and who to invoice means that there's high switching costs. You need to know who, essentially, you might be surrounded right now by multiple telco companies that could connect to you, but the one that you have on your SIM card may not have good reception in your area. So even though there are cell phone towers in your area that could be serving you, you may still have bad reception simply because the telco company that you have a contract with isn't present in that area. And your phone doesn't just automatically switch to the other one, even though it's present. So yeah, this identity really is a problem. You might also have issues when there's something wrong with your contract or you want to switch to a different ISP. You might find that it can get very bureaucratic and sometimes doesn't make sense from a technical perspective. So this is where Tollgate differs. Rather than needing to know who your customer is, or rather than needing to track this across long periods of time, your customer gives you a bare instrument. It's like it's blinded signature. So it's basically a string of text that an app on your mobile phone would give to the router, and then the router gives you 1 megabyte of internet. And before you use up your 1 megabyte, the app on your phone gives it another string of text to buy the next megabyte. And you're essentially in this loop where every time you've used up a megabyte, you buy another. But you can walk away from this router at any point in time without any significant sunk cost. And you can start buying internet from a different router. So now it's in the ISP's interest to undercut its competitor because the customers can move to the competitor at any point in time if they want to. So yeah, this is the idea, to maximize competition between internet service providers and create a true free market for connectivity. So yeah, let's do it live. I'm gonna show you guys my phone. Over here, I have an eCash wallet. This is cashew.me. And this QR code encodes a string of text. You can see the string down here. And I'm copying this string of text. I'm gonna go offline now. So turned off mobile data, switching to the Tollgate. Let's look at the logs as well on the terminal. Here, it's not responding. Sorry about this. We're not connected to there. No agreed. Okay, now we have the logs. And it picked up on the Tollgate MAC address, as you can see here. And I'm going to paste some eCash. This is the eCash we earlier copied. And buy some internet. As you can see, we bought internet. And it's tracking my usage over here. And I'm going to do a speed test on my phone. Here we're using more data now, so that you can see the usage is picking up. And it cut me off any moment now. I use some more. So my usage has hit 61 megabytes, and it cut me off because I ran out of data. So yeah, that's about it. Tollgate enables you to sell internet to anyone and buy internet from anyone without needing to know any identifiers. Next time my phone comes back and reconnects to this Wi-Fi network, my phone will have a different MAC address. And the Tollgate doesn't need to know or care whether it was the same customer or not. Does anyone have questions about this? We still have plenty of time. Let me see over here. So, good alternatives, different countries, 5G. Yeah, you can actually have multiple internet connections in parallel. So you could have a 5G connection and free university Wi-Fi and both of them. Or you could have a Starlink. And yeah, there's this thing called multi-WAN bonding, where you have multiple internet gateways and you share access, you bundle the speed from these gateways. So I might have a 1 megabit connection and a 4 megabit connection, and with multi-WAN bonding, I can turn this into a 5 megabit connection. And I could be the most reliable ISP on the block, and at the same time, also the cheapest, depending on where I get my internet from. Yeah, so I'm not sure if it's possible to ask questions here, but feel free to. We still have 22 minutes. Otherwise, what I'm going to do is I'll walk you through the config files. So what you saw here was the log. The way I access the log is, this is a regular OpenWRT router, by the way. I SSH in, and then 3 different names configured. Not sure how many people in this audience know. There's this thing called, this might be a good reference, this is open source banking software, where essentially anyone can run a bank that's backed by Bitcoin and issue vouchers. These vouchers are basically blinded signatures. If I give you a 1 sat eCash note, you can redeem that for an actual sat from the bank. So it's coin gift cards, essentially. But yeah, anyone can operate these. And yeah, so we use Cashew in Tollgate. This is the testnet mint. In the demo, we had just used minibits.cash, which is a popular one. Coinos is also a popular one. So after installing Tollgate, you should come here and configure which mints you want to use. You could also run your own mint and set it here. Part of the default is the developer split. The developers or maintainers of the software you've installed by default have a 21% split of your profit, and 79% go to you. But you can change this file anytime. You could set it to 0 if you want. So yeah, this is something to keep in mind. After installing Tollgate, you should change the defaults to have it do what you want it to. The rest is just details, Nostr relays, and which interfaces it pays attention to, etc., etc. But yeah, you should definitely change the defaults here, and you should also change the defaults around which mints you want to use. So the mints that you list here are the mints that your customers need to have eCash from in order to, it's the supported voucher types, basically. Then we have identities.json. Here you put your Lightning address. This is like a field for the owner. So you put your Lightning address in order to receive coin payouts from your router. One little thing to be aware of is here we have a payout threshold. Currently, for this demo, it's set to a very high number, but typically the defaults are 128 sats. So when you hit 128 sats, your router will send you a Lightning payment, but it always keeps these 60 sats on the router in case there's a different tollgate nearby and your router wants to buy internet from that tollgate. It can use these 60 sats to buy internet. So you can change this payout threshold, and you can also change the minimum amount that it should keep on the tollgate. Sorry, this is a min balance over here. So that's something to be aware of. Maybe you might be wondering, how do I install Tollgate? What you can do is, you can go to releases.tollgate.me. Here we have a Nostr client that shows you what releases have been published. These are signed Nostr events. They're signed by our build pipeline. And the Blossom server contains files, is OPKG file. So you can do, it's an IPK file, I think. So you can do OPKG install. This is like the OpenWRT version of apt-get, essentially. Now it's downloading, and it says we've already got the latest version. Another way to install Tollgate, if it's your first time on the router, you might want to go to OS images, and then you do, in this case, it's this one. There's compressed images, and there's the regular ones. Here, I'm not going to run this one now because otherwise the router will be out for a couple of minutes. But it sys upgrade -n. Oops, that was a bit quick. That wasn't good. Okay, I guess we're still up. Yeah. But yeah, that's something you can also do. Yeah, then if you have, after changing your config files in etc tollgate over here, these are your config files. The relevant ones are identities and config.json. You can restart the tollgate service by doing service and then log read. Yeah, so it's stuck now. As you can see, these errors are expected. We could clean up our logs. I'll do another purchase. This time I'll try a different mint. So I'll use this bank. The mints are the banks. I'll buy 4 sats because then we can also see me get cut off when I hit 62 megabytes or something. So I have this string. Note, I'm going offline. I'm completely offline. I have this string on my device. And now I'm going to connect to the router. Not this one. I'm going to connect to the tollgate. You see it's picked up my MAC address. And now I'm pasting the eCache to buy 84 megabytes. And there goes. I've bought the internet and I'm doing a speed test to burn through some data. And I got cut off successfully. Yeah, so that's about it. It's a pity we don't have audio here. Otherwise, I could answer questions. I see there's a question. Does the tollgate router need to be in the same country or close by for it to be connected to and used as a provider? Yes, unfortunately, the router needs to be within Wi-Fi range if you're going to buy internet over Wi-Fi. But you could use Ethernet or fiber. You have to be physically connected to it. This is not an overlay network. This is a physical network. But yeah, there are pico balloons, which that amateur radio enthusiasts use. And you could use a pico balloon to carry a tollgate if you wanted to. And you can also use long-range antennas. So you could have a 2-kilometer link over a directional access point and connect to someone really far away. You could also have a service provider connect you. So if you're far away from the free university Wi-Fi, but someone else is in between you and the free university Wi-Fi, they could set up the physical infrastructure to connect you to the free Wi-Fi. And if you think about it, depending where you are, you might be spending $30 or $40 a month on a fixed internet connection. And you could just cancel your contract and pay your neighbor. Now you have 2 neighbors sharing the cost of 1 internet connection, which means that you recover the cost of a $40 router in 2 months, essentially. And yeah, if 3 neighbors were to join, now you have, the more join the network, the cheaper it gets. So you quickly have a market that's worth serving. Someone far away can, if the ISP of your neighbor doesn't like how much traffic is flowing through that connection, like the KYC ISP can cut off your neighbor, and then anyone else can serve that market. So if you already have 10 neighbors connected to a gateway that just got caught up, you now have $400 a month worth of traffic or worth of purchasing power. And that's a market well worth serving with the Starlink or something. So yeah, I hope that addresses the question. There's another one. How does this compare to Helium? Helium, people are being paid in airdrops to establish connections, right? Here, this is just regular banking. It's backed by Bitcoin, and you could issue your own eCash as well, but there's no one subsidizing a connection. My understanding about Helium is that like people are rewarded for putting antennas like in areas that have no coverage, which for instance results in there being antennas in the desert where there are no users. And people are also rewarded for having lots of traffic flow over long distances. So they have like directional antennas pointed at each other on hilltops and just sending garbage traffic back and forth in order to collect the rewards. And this is something that we don't do in tollgate. There's no central planner issuing rewards for certain behavior. You need to figure out how to put your router in a position where it's useful to others and where it's serving others in order to get paid by the customer. We're not being rewarded for certain behavior by an authority, but we're being rewarded by the market for having served a customer. We're just transferring the internet, the infrastructure cost, rather than doing some sort of reward system. What would you say the best minimal requirements to serve customers is in regards to download and upload speed? It's very hard to form a generic answer. In Tollgate, we try to just make sure the gateway management and the metering is reliable. And then we try to get out of the way. We try to construct these config files such that they're as generic as possible, and so that the operator of the tollgate has maximal freedom to configure things as they need for their environment. There are settings where price is more important, and there are other settings where bandwidth is very important. Then there are settings where ping is important, latency. It depends very much on your market, and you as an ISP need to understand your market and figure out how to serve it. We try to get out of the way and let people set the prices themselves. Could this resolve HNS domains? It's a regular internet connection like any other, so I don't see any reason why it shouldn't be able to. We're thinking about, right now, tollgate routers are fully NATed. That means if you have 3 hops of tollgates connected to other tollgates, each DHCP server has its own address space that it controls, which helps with so each tollgate has its own DHCP server and distributes IP addresses to its users, which helps to keep the network architecture simple. But it also means that you can't typically run a server on a tollgate network because you're behind a NAT. So you would need a VPN or something called FIPS. I'll type it in the chat. Here, I can show you guys. FIPS, this is a new protocol. This is a new protocol for static IP addresses, essentially across networks. Both domains and IP addresses involve authorities where, like IANA and ICANN, distribute addresses. I realize HNS does things a bit differently. But yeah, while the domain stuff works normally here, or would work with HNS as well, we do hope to use FIPS in future so that we don't need to worry about NATing and things like that, preventing people from running servers. Yeah. Where does something like Starlink fit into this equation? Starlink connections can be expensive. I've seen prices of $80 a month. And I've also heard reports of people having their Starlink Wi-Fi passwords leaked in Africa, and suddenly there were like 30 people connected to their Starlink with their mobile phones. Yeah, this is a way to transfer the cost of your Starlink connection to the users, and you might be able to sustainably put up Starlinks in places where otherwise there might not be any. Or if you have data plans where a small data plan is costlier on a per megabyte basis than a large data plan, you might find that you can now afford to buy that larger data plan, and you're able to sell all that data because you have more users on the connection. It's not one user per connection, but multiple. Yeah, I guess did I miss anything? Yeah, so Starlink, that's how Starlink fits in. Again, you can have multiple connections as well. So you can fail over to the cheapest, or yeah, it's up to you and your business model. I see someone's popped into the call.
Hi, it's me.
Hi, Anne.
And yeah, good to finally connect with voice this time.
Thanks for having me.
Yes, a pleasure. And probably my last question would be if they want to connect. You have a really good lineup of questions here. So for sure, people from the audience would want to connect with you. So how can they reach you to collaborate and such?
Oh, yes. I don't know if you guys have Nostr, but there's npub.world. This is a good place to find people. This is my npub. Then you have, so npub, a public key. It's PGP without email. You can just send me direct messages on here. And this is the Tollgate npub. It's a shared npub. All the main Tollgate contributors share control over this. these are different Nostr clients, so you can use them for messaging us. Another way to contact us is by raising an issue. We're still on GitHub for visibility, but we use Git Workshop. It's a Nostr version of it. So you could create an issue on any of these repositories. Actually, since there are so many of them, perhaps it's best you create an issue on this repository so we don't overlook you. Yeah, so this is the one where we document the protocol specs. It's pretty outdated. And you can also meet us at conferences. So here's a list of all the conferences we were at last year. These are the planned conferences for this year. So yeah, you can meet us there. And feel free to send us a pull request to list your tollgate deployment. Yeah, I guess that addresses it.
All right, cool. Yes. So thank you so much for joining. And hopefully by next year, we can see some more demo with an HNS resolution.
Oh, yes, that would be awesome. I hope there's already a HNS, or I think someone showed me recently, there is a HNS OpenWRT package.
Oh, okay.
I think
There
it
you
can
go.
already run on here.
Oh, okay. Yeah. So let's have more talks about that after the session and yeah, going forward. All right. Thank you so
Thank you.
much. Tollgate.
Mhm.
Yes, that's the conclusion of the session. I'm happy you guys enjoyed the session. So we are going to have a chick chat for the next session. And yeah, by the way, just a reminder, when you join the following sessions and you don't hear anything after the ads, make sure to tap, yeah, it's the other side, tap the unmute button. Yeah. So thank you so much, Tollgate.me. And yeah, that's a wrap.
The 6th Handshake Conference, HandyCon White, Building the Sovereign Internet, wouldn't be possible without the generous support of our sponsors. Our platinum sponsors, Easy Domains, ShakeStation, Handshake Swap. Our gold sponsors, USwap. Our community sponsors, Handshake AU, Own the Dot, Namebase, GFAV IP Wallet. Powered by Sky Include. Thank you for believing in a decentralized future and empowering this community. Get your free ticket now at 2026.handycon.xyz